Hello, geometry students. Chapter 4 study guide here. Problem number 1. We want to find congruent triangles and name how we know they are congruent. By what postulate or theorem are we saying these are congruent? Now, let's go ahead and get started with this first one. For some reason, the file got all messed up and mine looked weird, so I had to write these in. So I think I wrote the triangles down correctly, but if I didn't, just let me know. Anyways, we know that triangle BEC is isosceles, and that tells me that that line segment is congruent to that line segment, because on an isosceles triangle, we do know that the legs are congruent. We also know that the vertex angle will be written in the middle, so triangle BEC has a vertex angle E. So after that, we are told that AE, line segment AE, is congruent to line segment DE, so we have those two. And finally, recognize that we have vertical angles right there. So, by the side angle side conjecture, side angle side, wow, that's messy now, let's get rid of all that stuff. By the side angle side, aka SAS, by the side angle side triangle congruence shortcut theorem, we know that triangle AEB is congruent to triangle DEC. So boop, boop, boop. Let's take a look at this next one. This time we know that point J, is the midpoint of line segment GI. If it's the midpoint, we know that it splits it into two equal segments. And we're also told that angle I is congruent to angle G. So I'm going to mark those as congruent. And then again, I have a pair of vertical angles right there in the middle. So this time, I know that I have two congruent triangles by the angle side angle theorem, the other sandwich theorem that we have. And again, triangle FJG, so 1, 2, 3, is going to correspond to 1, 2, 3. And how do I know? Well, I know that angle I corresponds with angle G. I know angle J corresponds with itself, and that only leaves points F and H corresponding with each other. So I'm going to write this as triangle HJG. Let's go ahead and do the third first problem. So now we know that Kn is congruent to Mn. We also know that Ml is congruent to Kl, and they share a side, so that is automatically congruent to itself by the reflexive property. And thus I have side, 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 and so I know that triangle KNL is congruent to triangle MNL. Problem number 1, part 4. We are told that AC is congruent to DE. Remember how we mark, sorry, I misspoke, not congruent, parallel. Remember how we mark parallel. Line segment AC is congruent to line segment DE. We also know that angle AB is, whoa, I cannot talk. Line segment AB is congruent to line segment BE. And remember what we know about parallel lines. We know that alternate interior angles of parallel lines are congruent. So we get those two angles are congruent. We also actually get those two angles are congruent as well. And we have vertical angles there. Holy moly, lots of congruent angles. So we can see that by angle, angle, side, we have congruence. We also have congruence by angle, side, angle. So it doesn't really matter which one you say this time, angle, angle, side, or angle, side, angle, depending on what you want to say. And finally, ACB will correspond to triangle EDB. Plowing straight through this problem. Look at this triangle. These triangles, I should say. Now we know that line segment EF is parallel to line segment DG. And again, if we have parallel segments, we know that alternate interior angles will be congruent. And those other angles are marked as congruent because they're both 55 degrees. And we have a shared side there. So we have angle, side, angle. And if they give us DEF, we need to respond with FGD. Boop, boop, boop. And finally, last problem, number 1. DE is congruent to line segment DG, so I have DE congruent to DG, so that's weird. They're not opposite sides this time, but that's okay, because I also know that GF is congruent to EF, which is pretty neat. And finally, again, a shared side there. So I do have a side, side, side congruence right there. And let's think about what corresponds to what. Well, can you picture this? Imagine if you took this point right here, E, if this was a piece of paper, and you folded it along that line, down like that, it would be right on top of itself. And so I can see that E corresponds to G, and F and D correspond to themselves. So I'm going to say triangle D. Instead of E, I'm going to say G, F. And finally, we're done with problem number 1.